Okay, so now I need you to practice answering some questions. If you go to your booklet, which you should all have at home with you, but I will attach a copy if you don't. If you flick to page 25, you'll see the theory. Okay, so this is what I've just talked through. So end of page 25. Then I talk here about concentration. Please read my worked examples. Okay, they just tell you the sort of questions you're going to be asked in an exam, and they tell you how to answer it. And you'll see I've underlined more frequent every single time. You need to have that words more frequent collisions in your answers to get the marks. So please look at my worked examples, because they will show you the typical types of questions you will get asked in an exam and how to answer them. So have a flick through, even if you're totally comfortable with what we've done in the last video. Worked example, worked example, worked example. Okay, so you only need to go as far as page 28 when you're reading. The rest of it you can disregard for now. And then scroll down to exercise 4, which is the questions I want you to do. So here, I want you to pause. I want you to go back and read the worked examples, and then I want you to do questions 1 down as far as question 6. So just do 1 to 6. So read through the worked examples, come back to exercise 4, do questions 1 to 6, then unpause me, and I'm going to go through the answers. Okay, so hopefully you've actually done the questions yourself, and you've only gotten this far in the video because you're correcting your answers and you're not just going to copy down everything that I do. Please, please, please have done these yourself. There's no point in just copying my answers. I'll turn on my little pen. So I'm going to go through the answers. Describe what must happen between particles if they are to react. Okay, they have got to... Ooh, where's the pen? Right, black. They have got to collide and with sufficient energy. Okay? If they're not colliding with energy, you are not going to have a reaction. Okay? Explain why the acid in your stomach is more affected at digesting food if the food has been chewed. So I don't really have space to write this full answer, but what you would need to say is when you chew your food, you are increasing the surface area. And if you increase the surface area, you are increasing the frequency of collisions, and therefore you are increasing the rate. So that will be a 3-mark question. 1 mark for increased surface area after chewing your food. 2nd mark for for increasing the frequency of collisions. Your 3rd mark for saying you're increasing the rate. Remember, it is a chemical reaction that's taking place between the acid in your stomach and the food that you've eaten. So the same rules apply as if you're doing a normal reaction in the lab. A student wishes to investigate the rate of reaction of marble chips with acid and different temperatures. Explain why the student must use the same size chips for both experiments. Okay, so he's investigating temperature, which we haven't actually looked at yet, but it's asking you why you have to use the same size chips. So we've already seen when we looked at surface area that if you use different size chips, that's going to affect the rate of the reaction. And if you're looking specifically at temperature, if that's what you're investigating, then everything else has to be kept exactly the same to make it a fair test. So you can just write to make a fair test. But to go further than that, and you should, okay, as well as writing to make a fair test, you would say that the size of the particles affects the rate. Therefore, that is a variable that you have to keep constant. You don't want it to mess your results. The graph to the left shows the amount of gas produced when medium-sized chips of calcium carbonate are added to acid. Draw a line to predict how much gas will be produced for. So if I'm using smaller chips of calcium carbonate, okay, if you're using different sized chips, but you're still using the same amount of chips, if you're using smaller sized chips, you are going to get a faster rate of reaction. Remember, smaller chips means more frequent collision, means a faster rate of reaction. So when I'm drawing my line here to show that the reaction is faster, I'm going to draw it steeper. So I'm still going to start here at 0, but I'm going to draw it steeper. So I'm drawing it steeper, but you'll notice that I'm still ending my line at exactly the same place. Yes, your reaction is going faster because you're using smaller chips, but if you're using the same amount of chips in total, then you're going to get exactly the same amount of product produced. Okay, you're using the same mass of chips, but you're using small chips instead of medium chips. You're still going to make the same amount of product, but with the small chips, you'll make that product faster. So this is my answer for A. sorry. This is my answer for 4A. If I was to do large chips of calcium carbonate, I need the line, but it can't be as steep. So I'm going to be drawing it over here. To be fair, I'm going to run out of room before I can get to my maximum volume. But if this graph was bigger, you would see that I would eventually reach the same volume of gas. It would just take me a lot longer, and on this graph I'm running out of space. Okay, but the important part is to have 4A steeper and for B less steep. The reaction is going to go slower. Explain your answers. That's what I've already said. Small chips increase the rate, and the larger chips decrease the rate. I'm representing that in the graph by the steepness of my line. Question 5. A student investigates the reaction between magnesium and hydrochloric acid, blah, blah, blah. Which test tube had the most concentrated acid? So if it's the most concentrated, you are going to see the fastest, most vigorous reaction. And I can tell by looking at test tube B that it has had the most concentrated acid because I can see the most bubbles. Okay, so you're basically just counting bubbles. That tells you that the reaction has taken place vigorously. How can you tell from the diagram? It has the most bubbles. Which test tube had the least concentrated acid? So which test tube has the least amount of bubbles? That, from what I can see, is going to be A. Okay. Once the reaction in each test tube is finished, which one will have produced the most gas? Okay. So they're telling you that you're varying the concentration of hydrochloric acid, which means in test tube B, you have got more hydrochloric acid than you have in the other 3 test tubes. If you're starting out with more acid, you are going to make more product. So you will produce more gas in B than in any of the others because you've got more reactants to start with, okay? It's like if you're baking a cake, if you started off with more ingredients, you would end up with a bigger cake than if you started off with less ingredients. Suggest one control variable for this experiment. Okay, so you will see that the piece of metal that they are reacting with, so the size of magnesium is the same, okay? You can't have different sized pieces of magnesium because that will change the rate of the reaction. You could also say, we haven't looked at this yet, but you could say that the temperature is the same. As we'll see later, temperature affects the rate of the reaction. Okay, temperature is going to stay the same. You're not going to talk about pressure here because, as I said, pressure only applies to gases. And in this case, you're reacting a metal and an acid. You're not reacting gases, so you're not going to talk about pressure. States the effect of increasing the concentration on the rate. As you increase the concentration, I'm just going to write all this down here. As you increase, oh God, what have I done? As you increase concentration, you increase the rate. And to explain that, you would say you have more particles, therefore you have more frequent collisions. The last one we're going to do is number 6. Methane reacts with steam as below. Okay, and you can see that all of your reactants and your products are gases, which is why they're now asking about pressure. Pressure only relates to gases. State and explain the effect of increasing the pressure on the rate of the reaction, and this is for 3 marks. To get your 3 marks, I'm going to write my answer over here. To get your 3 marks, you're going to say increasing pressure increases the rate. Then you need to give a reason. You've got less space, so that gets you a mark, less space. And then for the final mark, so the particles or molecules, you can say, collide more frequently. Those words, more frequently, have to be included in, have to be included in your answer, okay? You can't just say collide more. You have to say collide more frequently. And I'm just going to go back and find an example so I can show you why. So if we look at this, we haven't looked at temperature yet, but I just want to explain why you can't say collide more. So in this graph here, which I'm going to make, oh no, what have I done? In this graph here, which I've made a little bit bigger, okay, you've got 2 reactions, one going at 40 degrees and one going at 20 degrees. And we can see that the 40-degree reaction is happening faster because that line is steeper, Okay, let's just say for argument's sake that in order to make this 40 centimeters cubed of gas, which is how much you're making, that required 100 collisions between the reacting molecules. Okay, you will see that at 40 degrees Celsius, those 100 collisions happened faster than at 20 degrees Celsius. But even though it took longer, at 20 degrees Celsius, you did still end up with 40 centimeters cubed of gas. And if you're ending up with 40 centimeters cubed, then those 100 collisions also took place at 20 degrees. It just took longer. That's why when we're talking about this, I can't say that I'm getting more collisions at a higher temperature, or more collisions at a higher pressure, or more collisions with a greater surface area. You're still getting the same amount of product, so you're getting the same amount of collisions. What the difference is that those collisions are happening faster. So we say there's more frequent collisions instead of more collisions. So all of the answers that I've written for you down here, okay, you'll notice that I have written all of your worked examples. I have used those words more frequently. Okay, and it's really important that you do too. You won't get a mark for saying particles collide more. You have to say they collide more frequently. If you've got any questions, If you've got any questions about any of this, okay, just message me and show my homework. We should hopefully have Teams up and running by next week, which will make it a lot easier to communicate with each other. But for now, just email me or message me on show my homework, and I'll do my best to get back to you as soon as possible.